episode 21 of PVTV, where we talk all things solar. On today's episode, I wish Ross a Merry Christmas.
Merry Christmas to you too.
And we're also going to review a solar installation, actually a solar and battery installation from start to finish by yours truly. And then we're going to have a look at the impact this solar system has had on our customers' electricity bills over the last couple of months and see whether it's paying for itself or it's not paying for itself, and whether solar and batteries might be something worthwhile. So we're just going to open up the LG Chem. This is an LG Chem Solar Battery, 10 kilowatt hours and high voltage. So this particular model is compatible with the Sunny storage, which we'll be using to link up to the solar system, the Sunny Boy, and communicate all together as one cohesive unit. It means you can see the battery in the app, it means you can see the solar in the app, and you can also see how much power the house is using at the same time, which is a really powerful tool when managing your energy usage. So you've got your wall mounting bracket here. Your manual, which is going to give us our clearances and how much ventilation space around it that the battery needs. This is your wall mount bracket for the LG Chem high voltage. And if we pull this up here, there she is. Absolute beauty. This guy actually comes with a hair, this one, so that hair's probably come all the way from Korea. But yeah, there she is.
So we just done some measurements. Turns out the height here is not going to be enough to have the battery and the inverter on top of it. The airflow goes from top to bottom, so the SMA Sunny storage wants about 700 underneath, and the LG Chem needs about 600 mil underneath, so there's just not enough space here to put it. So we've decided we'll put the battery here and the Sunny Boy storage here, or vice versa, either one will work. Now mounted with great difficulty. It's now on the wall, and we'll just put some cables in. So we've got a 4mm DC cable, very important, an earth cable as well, and another Cat5 communications cable, which will keep communication link with the Sunny Boy storage, and that's the way the storage can tell the battery whether to discharge or charge. So we'll just hook all that up now and almost done. Battery here. So we've got our DC cables, put bootlaces on the end of these, and they go straight in. Put a bootlace on, you can just push them straight in. Earth as well, just put that in there.
I can see your battle wound from lifting the battery up.
Yeah, there you go. And then the Cat5 can be a little bit tricky, but what you basically want to do is just strip a little bit off the Cat5 there, and remember your color combinations here, and you basically just push that in there, push your screwdriver in and push it in, and pull the screwdriver out, and it'll be tight in there. So just do that for all of them. Remember, just give them all a tug to make sure they're all in there tight, and then they will match up with these here. We need to remember that for when we fit off the battery, because that's how the communications will work. And then once we're done, we will plug these into each other, but we won't do that till we're finished, till we're turning it on. So we'll leave them out for now, because if you leave them plugged in, the battery will drain itself.
that's a solar and battery installation.
Cool.
Good work, Ross.
Thank you.
Well, now we've seen what the actual installation looks like with the solar. How much? It was 6 kilowatt, 6.6 kilowatt,
6.6 kilowatt solar.
which will generate on average in our state of Victoria about 24, 25 kilowatts a day.
Yep.
On an average day, a lot more in summer and less in winter. Now, I'm sure everyone's curious to hear about how this is actually impacting Serge's electricity bills and the difference it's making to his home. So maybe, Ross, you could show us, after doing such an awesome install, what it's actually doing in real life and in practicality for Serge.
Yeah. So when it gets set up, you basically get set up with a online monitoring portal, and with SMA you get Sunny Portal. So the first screen you get here is just the dashboard, which shows you a real-time reading of how much power you're using and where that power is coming from. So as of right now, the house is drawing 368 watts and it's all coming from the battery. So zero consumption from the grid at the moment. And if we go in the options here, we can actually see. So this window here shows that the battery is discharging and the consumption's 360 watts and nothing is coming from the grid. So that's real times, and that's what Serge can look at any stage and see how much battery charge he's got. And you can see he's got 90% left here. So it's actually 9:20 p.m. at the moment, and he's still got 90% left in the battery. So that's doing pretty good. So what you can also have a look at is the energy balance. So this is the snapshot of how much, where your power is coming from and how it's being distributed in the house.
So this is from today as well, is it, Ross?
Yeah, so this is from today. So it's the 19th of December. I'll go back a week, so to the 12th, so we can get a bit of a last week's view. If we have a look at this, we can see the bottom graph here is the solar generation. So this day probably wasn't a great day in terms of sunlight, but we can see that this dark orange section here is where the battery was charging. By approximately 11 a.m, it was fully charged, and then the system was actually exporting to the grid for the rest of the day, while it's also taking care of his usage.
Exporting means that the solar system's generating more power than not only the home needs, but then the battery needs as well.
Yeah.
So the battery's fully charged, the home's needs are supplied, and there's extra, so the solar system is actually selling that extra power back to the power lines for a nominal rate.
And the battery's charging really fast, so it's charging by about 11 or 12 o'clock in the morning. But as you can see on the consumption graph,
orange part is the part where it's charging.
Yeah, the dark orange, so the bottom part here. The light orange is where the battery is actually discharging.
So that's in the graph just above that one?
Yeah, so you got your consumption graph on the top and your generation graph on the bottom. Now, when you're drawing power from the grid, your consumption graph will go red. As you can see, there's absolutely no red in this graph at all, which means we're not drawing...
home's fully self-sufficient.
Exactly. So it's charging really fast. By approximately 10 a.m. it's charged, and then it's exporting all day, and then it's actually getting surged through the whole night, which is all this section here. And I'll go to the next day and the morning, and it's also taking care of that morning spike of power as well. So the battery's getting through the base load of the night, and then in the morning everything sort of turns on and it's taking care of that as well. Then the solar starts to kick on and starts to charge the battery again. Yeah.
So we're saying that the home is on these days 100% self-sufficient.
Yep.
So since having the solar and batteries, this home is virtually drawing nothing from the power lines, and it's actually set up in such a way that if there's a blackout, the home can run entirely self-sufficiently from the battery, even when the home or the neighborhood's in a blackout, which is really cool technology. Right. Now I'm curious, are these just really good days, Ross? I know we're in summer at the moment and we have been for the last couple of months. So Serge is 100% self-sufficient. Do we have any examples of what a bad day might look like for this solar system?
Well, I'll put the months back a little bit. So September is when we put it in, September 5th. So I'll go to it hasn't really been, it's only really started getting sunny recently. So we'll go back to September and look for some, I can't actually find a bad day. But even on the bad days, I think the point is it doesn't take much solar for these batteries to charge up. So most days, every single day I'm looking at here, the battery is just, when it can, the SMA inverter will pump so much power into the battery so fast that within 2 or 3 hours it's fully charged. And then it's lasting most of the time all through the night and all through the morning. So if you have a look at this example again, like you can see the sunlight sort of going up and down as a normal cloudy day probably, but just that little bit of morning sunlight is just absolutely hammering the battery, and it's just charging super fast.
Yeah, and this is important because you can see how huge that block of yellow generation is.
Yeah.
And this is something I think a lot of people don't realize when it comes to modern solar systems, is that for most family homes, your average size solar system of say 5 kilowatts is going to generate far more power than you're going to need during the day.
Yeah.
So people still get electricity bills because when nighttime comes around, then even though they've made heaps of solar power during the day, they're switching over to the grid at nighttime and generating an electricity bill.
Exactly.
So this is a great example of, you can see how much solar power the home's actually generating and how quickly it can actually charge a solar battery to mean you're fully self-sufficient at nighttime.
Yeah, and if we finally go to, we'll just go to the total graph. So this will give us the total since the system has been installed, where our power came from. We can see that we consumed 1,219 kilowatt hours. 44 of those came from the grid.
So say that again.
So of the 1,219 kilowatt hours that Surge used since we installed it, only 44 came from the grid. The rest.
What's that as a percentage?
I'll quick maths in my head.
I'm just teasing.
But it is actually 3%.
3%. So Surge has got solar, which is a 6.6 kilowatt system. It's actually quite an average size solar system these days. He's got a 10 kilowatt hour LG Chem Solar Battery with an SMA Solar Inverter, and he's 97% self-sufficient.
And to add to that, he exported 1,500 kilowatt hours.
Which you'll get paid for. So that means the 3% that he had to pay the power lines for, they're actually going to pay him for how much?
1,500 kilowatt hours worth.
And it's usually about what, 10 cents?
Yeah, about 10 cents.
Per kilowatt?
Yep.
So Surge is in profit. Is that right? Is he in profit?
Yeah, it is, because he only paid for 44 kilowatt hours.
Yeah.
And he got credited for 1,500.
Yeah, it's a big difference.
Yeah, huge difference. So he'll be that export would well and truly be covering the small amount of grid usage that he's used. So
there you go. And this isn't a huge solar system again.
Yeah.
6.6 is an average size solar system. 10 kilowatt hours is your average size solar battery. So this isn't anything crazy. And this is a family home we're talking about as well. You know, there's kids.
Yeah, exactly.
There's quite a few people living in this house, fully self-sufficient in suburbia, fully covered if there's a blackout. They can run the home 97% sufficiently in a zombie apocalypse.
Yeah.
And that's really cool technology that this is at our fingertips now. And this is something that is available to everyone.
Yeah.
It's exciting.
Amazing.
Yeah. So 4 months, Surge has had his system, 97% self-sufficient. You did a pretty bloody neat install.
I did, yeah.
Am I allowed to say bloody on YouTube?
We'll beep it out.
And that's it. So thanks for watching, guys. That's been episode 21. Is there anything else you'd like to add, Ross?
No, not really. That covers it.
Well, good. Merry Christmas, guys.
Merry
Trust you've all
Christmas.
been well, and see you in the new year.